In this video we are going to learn about number system. It is very simple. Once you understand the theory, nothing to memorize. Now there are 4 number systems. This is the common number system we'll be using, that is base 10, right? Binary, the computer system use always 0 and 1. The base is 2. Octal, base is 8. Then numbers 0 to 7. If any octal number represented using number 8 or 9, then that octal number is wrong, because these are the possible digit, right? And similarly hexadecimal, there will be 0 to 9, and from A, then from 10, A, B, C, D, E, F, this is the value is 15. Very simple. Now see, here we have got the binary value. We want to represent in decimal. Simply you see the weight here, right? Nothing to memorize. You should be able to write this, that's all. Here see, 2 to the power 0 mean 1. So the weight, always the weighting factor we should be able to write here. For binary, 1, 2, 244, 488, 16, 32, 64, 128. Then wherever you see 1, you take those values, and 0 don't take those values and add up. Very simple. Now see here, the place value is 128. So here 128 multiplied by 1. Then here the place value is 64, that multiplied by 1. Here place value is 32, that multiplied by 1. Then 16, 0 we are not taking. Even if you multiply you get 0. Then 8 you are taking here 1 into 8. Then 4, 1 into 4, and this we are not taking. Very simple. Only you should be able to write this weighting factor, that's all. Wherever once you take the value, for 0 don't take the value. Finally you can take the answer here, 237 base 10 equivalent to this binary. If you put all ones, what will happen? Maximum possible value is 255. You can, then you will be adding all these, because all ones, no, all values need to be taken. 1, 2, 4, 8, 6, 32, 64, 128. To add up it will come 255. Similarly octal, the base is 8, right? Here the weighting factor is any number to the power 0 is 1, no, always starting from 1. Then here the value is 8, here the value is 64. Then 64 multiplied by 2. Then here 8 to the power 1, 8 into 3. Then 8 to the power 0 is 1, 1 into 6, and you add up. Very simple. Only the weighting factor you should be able to put. In the binary, 2 to the powers. In octal, 8 to the powers. Hexa, 16 to the power. Once you put the weighting value, you know the value here, right? Now 16 to the power, always any number to the power 0 is 1. So here the weighting factor will be 1. Next weighting factor will be 16. Then 256. Then 4096. So here only 3 numbers, no? So then 1, 16, 256. So then 256 into 1, 16 into 5. Here the value is 5. The place value is 16. Then here the place value is 1. So E mean we know A 10, then B 11, C 12, E 14. So then 14 multiplied by 1, you are converting to the decimal. Very simple. Any number to the decimal value, only we need to know about the weighting factor. You can just write the weighting factor. This is, even these powers you no need to write. If you can put these values, okay, right? Very clear. Then binary to octa, hexa or decimal. So decimal is very clear. Only you need to take the weighting factor, no? Now when we are converting binary to hexa, we need to remember this. Maximum value in hexa is F. To represent F, we need only 4 bits. Here the place value is 1, here the place value is 2, here the place value is 4, here the place value is 8. If you add up all and see, it becomes 15. 15 mean F. That means to represent F we need only 4 bit. That means all other hexadecimal numbers you can represent using 4 bits. Individually you can represent. Now see, once you get a binary number like this, if you want to convert it to hexa, you group from here, right? From here to here 4. Then next 4. 4, 4, 4. Likewise you need to group from here. Now see, once you group this, the value will be 8. Once you group these 4, the value will be 7. 4, 2, 1. Once you group this, value will be F. Here the value will be 1. Here the value will be 7. And here the value will be 8. Finally you can write this. Very simple. Only you remember hexa 4, octa 3. Why? The octal, the maximum value is 7. You can represent 7 using 3 bits. So therefore all other numbers can represent using 3 bits. So now this is the binary value, right? The long binary value. Now if you want to convert it to octal, you group 3 from here. 3, 3, 3, 3, 3 and put the value. That's all. Here the 0, here value will be 7, then here the value will be 5. Why? Here the value is 4, here the value is 1, 5. If all 1 means 4 to 1 will be 7. So here the value will be 1. Here the value will be, here no value, then here you get 2 and 4, then 6. Here the value will be 1. Here the value will be 1, 2, no, here 4. So likewise individually, right, you group into 3 and you write the value individually. Then you are converting here the binary to octal. Very simple. Then octal to binary. Now this is the octal number. If you want to represent in binary, each and every digit you take separately. 7 you represent separately using only 3 bits. Then 5 using another 3 bit and 4 using another 3 bit. Finally you can write 457 octal value is equivalent to 100, 101, 111 binary. Similarly hexadecimal to binary mean these individual digits you need to represent using 4 bits. 4 bits. Then the entire thing will be represented in binary. Right? Now it is very clear. There are no direct conversion between octal to hexadecimal. Therefore the best method, first you convert octal to binary, then you group 4, 4. Right? If you want to convert octal to hexa, first convert octal to binary. Now see, with number system if you try to memorize, you get really confused according to the question, the calculation, right? Octal to hexa, then you know octal to binary. Oct mean only 3 bits needed, so using the 3 bits you write this in binary. Then if you want to write binary in hexa, you know hexa 4. Only these things you need to remember, hexa 4, octa 3, that's all. Then you group from here 4, 4, 1, 1, 1, 1, here it will be 4, another 4, another 4. Then you separately write. Here the value will be F, here the value will be 2, and again the value will be 2, 2 to F16. Very simple, right? Octal to hexa or hexa to octa, all same. Right? Then hexa to octal. Here see, this is in hexa. So you first write in binary using 4 bits for each and every individual digit. Then you group from here 3, 3, 3. Here 0, 1, 0, 1, 1, 1, 0, 0, 1, 0, 0, and write it in octa. Very simple, huh? Hexa 4, octa 3, that's all. Whatever the conversations comes, accordingly you can calculate it. Now if you go to color palette and you apply this value and see, exactly you get this color. Red 135, green 31, B 120. This is RGB color system, but certain advanced graphic system directly use hexa value. Instead of RGB, you can put the hexa value. Now see, 135 you can represent, right, using binary. Now to represent a decimal number in binary, the simple method is, now 135, you see 135 is closer to which weighting factor. Now here you know 1, 2, 4, 8, 16, 32, 64, 1 to 8, likewise you will be getting now. So 135 is closer to 128. Then you put here 1. What is the remaining? 7. How you can represent 7? Make these 3 bits 1. Then finally you will be writing 135 decimal is equivalent to this binary. Clear? So here you will be getting 1 1 1, then all others will be 0 and 1. This is the simple method. Now see 31 decimal. 31 is closer to 16. 31 is closer to 16. Here 1, 2, 4, 8, 16. Then you put a value here 16. 1. Then 16. Then 15 balance. Then the 15 is closer to 8. You can't take higher value, always the low value. Then here you put a 1, 8. Then 7. Then 7 is closer to 4. You put a value here. Then 3 remaining. 3 is closer to 2. Put here 1. Then 1. Then this is 31. Similarly 120. 120 is closer to 64. Right? Likewise you can see the remainder. Then from remainder next value comes here closer. Closer to this. Likewise you can write. Otherwise you can simply divide by 2 and go. 135 and 31 divide by 2, put the remainder. I will show you that finally, but this is also very convenient method, right? First you take the closer value and the balance closer value. Likewise wherever you need you put 1, others you leave it as 0. And finally you can write here the 135, this is the binary format. Then 31, this is the binary format. Then 120, this is the binary format. Now you convert this entire thing to hexa and see whether you will be getting this value. H is for the hexa, right? Otherwise they put hash. So this is the number 871F78. You see whether you will be getting this value. Now binary to hexa mean nothing to memorize. You memorize only 4. So you group from here 4 4 4 and you will be getting this. You can try that. Right, now I told you taking the closer value also you can conveniently write any decimal to binary. Other method is to convert any number, right? To convert any number you divide by that particular base. Now let's say 46 you want to convert it to binary. The binary, what is the base? 2. So you divide by 2 and go like this. 2, how many 2's are there? Put the remainder, put the remainder, put the remainder, put the remainder. Till this point you need to divide it and go. Now for 1, 2, no 2's and remainder will be 1. Then you write it from down to up. And here this should come here, here to here. Because it is a binary you are dividing by 2. If it is octal, decimal to octal, you divide by 8. Very simple. Put the remainder till this point you divide it and go. And write from here to here. right? It's very simple. Then hexa base is 16, so you divide by 16 and put the remainder. 15 mean it is F we know, right? Then for 2, no, the remainder 2, right from here to here, 2F. Certain times you may get the tricky questions like this as well, right? Now I'll show you. Now here in the ASCII code, the letter A is represented as decimal 65. Determine the binary representation of the letter D. Now see, A, then B, C, D. So A is 65, then B is 66, C 67, D 68. So then take 68 and write it in binary. Now you know two method. Straight away you divide by 2 and go. Otherwise 68, you see 68 is closer to 64. Then you make that particular bit 1. Then 4 remaining. Straight away you can go and on the value 4 and put all others 0, and you can represent in binary. Now he is here. Character A decimal 97, hexadecimal 61, binary this. Ask him what is octal. So here straight away you can use this and convert. Very easy. You know, no? Octal mean always 3. So you group all this from here 3 3 3. Then this will be 1. Then if you group here, it will be 4. Then only this is remaining, no? So then you can put 0 0 here. Then again it will be 1. So 1 4 1 in octal. Always from here only you will be grouping. This 3 digit separate value you write. Then this 3 digit separate value you write. Then here only 1 remaining. No, this is the, then here you can just put 0, 2 zeros. Then here the value will be 1, 1 4 1. How many different colors can be represented if 10 bit per pixel is used as color depth in an image? You know, no? How many combinations you can make? That's all. 2 to the power 10. Then 1024 colors. Always combination. 10 bits mean 10 possible combinations. Then 2 to the power 10. If we have only 3 bit, only 8 combination. 2 to the power 3. 0 0 0, 0 0 1, 1 0 1, 1, likewise combinations. Now here, if the character A is represented as this in ASCII coding scheme, what character will be represented by this? Now you take this value and see. This is 65, right? Then you take this value. What is this value? Here 64, and here the place value 1 2 4. Then 68. 64 plus 4, no? 68. Then 65A. Then 67B. 68C. Likewise, very simple. You take this decimal value and see this decimal value. See how many places. 65A, then 66B, 67C, then 68 is D. It's D. Which of the following represent the given 4 number in the descending order? Now these are in different bases, no? So therefore I think the convenient way is represent all in binary. Very simple, no? This is in decimal. You know how to represent in binary. 157 is closer to 128. Then take the remaining value. Then next closer value put 1 and make all others 0. Then this also will be in binary. And this is very easy. Just using 4 bits you can represent C and the 9. Then here you can use 3 bits and represent 3 3 and 2. Then all will be in binary. Easily you can see descending mean higher to lower value, ascending mean lower to higher value, right? It's very simple, nothing to confuse. Only octal 3, hexa 4. That only you need to remember. Whenever you see the question, you should know how to group it. If it is given in the binary, then if it is given in the octal, to convert to binary, you know each and every digit you need to represent using 3 bits. If a hexadecimal value is given, each and every digit should be represented using 4 bits. Very simple. So once you understand, nothing to memorize. Stay tuned for the next video. Thank you.